Okay, in this video, we are going to be discussing deductive structures. A deductive structure is a thought system where conclusions are justified by previously assumed or proved statements. We've actually already been using deductive structures when creating our two-column proofs, so we're going to continue to learn more about them and why we are doing the two-column proof. A postulate is an unproved assumption. One example of an unproved assumption that we've already been using in honors geometry are straight angles. We know what straight angles are, but we never proved a straight angle. So that would be one example of an unproved assumption that we've already been using in proofs. The next vocab word is a definition. A definition states the meaning of a word or concept. Some definitions that we've already been talking about in honors geometry would be midpoint or bisect or trisect. Those are just a few examples of some of the definitions that we've already discussed and been using in our two-column proofs. Now the next vocabulary word is called a conditional statement. A conditional statement is typically written as an if-then sentence. So you start with if something, then something else. To represent this symbolically, we typically refer to our conditional statement as if P happens, then Q, or if P, then Q. So we'll get to some examples in just a minute of conditional statements. Now the converse is just the reverse of the conditional statement. So you would go back to your original conditional statement and you would simply reverse the if part and the then part. So symbolically, we would refer to the converse as if Q, then P. So keep that in mind as we go through some examples later on. Now, a few things to keep in mind are definitions are always going to be reversible. So anytime we have a definition in honors geometry, we can always reverse it depending on how it is being used in our two-column proof. One example of this would be the definition of a midpoint. If a point is the midpoint of a segment, then it divides the segment into two congruent segments. The reverse of this would also be true. If a point divides a segment into two congruent segments, then it is the midpoint of that segment. Theorems and postulates, on the other hand, are not always going to be reversible. One example of this would be the theorem that we learned about if two angles are right angles, then they are congruent. The reverse would be if two angles are congruent, then they are right angles. That is not always going to be the case, so that would be an example of a theorem that is not reversible. The key to being successful in proofs and in honors geometry is taking time to memorize all of the postulates, theorems, and definitions. Okay, so now let's take a look at some examples. So we're just going to look at one example so you can kind of get the hang of it. I want you to write the conditional and the converse of the following statement. All Lake Park students are in high school. So to begin with the conditional, remember the conditional statement is written as an if-then sentence. So if P happens, then Q. So we need to turn this sentence into an if-then. To do this, we can write this as if you are a student at Lake Park, then you are in high school. That would be our conditional. If you are a student at Lake Park, then you are in high school. Now, pause the video here and see if you can write the converse of that statement. Then, when you're finished, hit play to check your answer. So the converse of the statement is if you are in high school, then you are a student at Lake Park. Notice the conditional statement is true, but the converse statement is not true. So you may be asked to look at the truth of the statements. This is an example of a conditional statement that is not reversible, just like some theorems and postulates are in geometry. So hopefully now you have a better idea of deductive structures.